All right, today we're diving into something, well, truly mind-bending, a theory of everything. But what if I told you that physics, time, and maybe even our own consciousness are all woven from the exact same fabric? It's a seriously wild idea. And get this, it didn't come from some high-tech lab. It actually started as a dialogue, a conversation, and it's one that might just flip everything you think you know about reality on its head.
Okay, so here's the game plan. First, we're going to look at a real problem, a genuine mystery that's got scientists scratching their heads right now. Then we'll dive headfirst into this new framework. We'll see how it tries to completely reimagine our 3D world, redefine the forces of nature, and, make some really out there claims about what it means to be alive.
You know, any big, bold new idea usually pops up because there's a problem it's trying to solve, right? Well, for this one, the problem is a biggie. It's a real, fundamental disagreement that's happening right now in physics. They even have a name for it, the crisis in cosmology. So what is this crisis? Well, it all boils down to one simple question. How fast is the universe expanding? The number that tells us that is called the Hubble constant. Here's the thing, though. We have two really, really good ways of measuring it, and they give us two totally different answers. And I'm not talking about a small difference. They are way off.
Okay, so here's the breakdown of the problem. On one hand, we can look way, way back in time at the faint glow left over from the Big Bang. And when we do that, the data tells us the universe is expanding at a certain slower speed. But then, if we look at things much closer to us, like exploding stars in the more, modern universe, we get a different number, a faster one. And both of these methods are super precise. So this isn't just a simple mistake or a rounding error. It's a major contradiction, and it's basically screaming at physicists that we're missing a huge piece of the cosmic puzzle.
So this is where that new radical framework we talked about comes into play. How does it even begin to tackle a puzzle like that? Well, it starts by doing something pretty wild. It completely changes how we think about the present moment. It suggests our reality isn't really what we think it is at all. At the heart of this idea is something called the time surface. Now, try to picture this. Our entire three-dimensional universe, right? Everything you can see, touch, and experience as now is actually just the surface of a much bigger four-dimensional reality. Think of it like a balloon that's constantly inflating. That whole balloon is the 4D reality, and we're just living on its expanding skin. Or, hey, here's another way to look at it. Think about an old movie projector. You only ever see one single frame on the screen at any given moment, right? That's our now. But that one frame is part of a huge, long roll of film. That's the fourth dimension. So what we experience as time passing, it's really just our 3D frame moving along this massive 4D film strip. Kind of cool, huh? Okay, so if our whole reality is just a moving surface, a single frame in a movie, then what's making all the stuff on it? Where do particles and forces and all of that motion actually come from? Well, this is where the theory gets its name. The theory says that the ultimate building blocks of everything are these things called filaments. Imagine them as one-dimensional strings, just existing in that bigger 4D space. Now, every single thing we call a particle, like an electron or a quark, isn't a thing in itself. It's just the exact point where one of these 4D filaments pokes through our 3D reality, through our time surface, like a needle poking through a sheet of paper. We only see the tiny dot. And here is the really clever part. All the complicated motion we see in our world, it's supposedly just a shadow of simple geometry happening in that higher dimension. Think about it. If a filament pokes straight through our reality, perpendicular, what do we see? A dot that's not moving, a static particle. But what if it pokes through at an angle? Well, then the intersection point moves, and we see a particle with constant velocity. A curved filament gives us acceleration. A filament shaped like a corkscrew? Damn, you've got an orbiting particle. Suddenly, all of physics just becomes geometry. And what's really elegant is how this whole idea scales up. It's just like how you twist tiny threads together to make a strong rope. This framework says that single filaments are your basic particles, like quarks. But then they braid together to form threads, and those are your protons and neutrons. Those threads weave together into twines, which we see as atoms. And it keeps going. Twines become yarns or molecules, all the way up until you have these gigantic ropes of filaments that show up in our world as planets and stars. It's all just weaving. Okay, but let's be real. Any theory of everything that's worth its salt has to explain the big one, gravity. So how on earth does this 4D filament idea try to explain the most familiar force in the universe?
Well, in this model, gravity isn't really a force in the way we usually think about it. It's just the result of all these 4D filaments tugging on each other. And this is a huge but, because these filaments stretch across all of time, those tugs aren't just happening right now, in the present. The theory says gravity is the grand total of all interactions from the past, the present, and yeah, even the future.
Yeah, let that sink in for a second. This leads to a pretty stunning idea. It means that some huge event way off in the distant future, let's say a black hole forming, could literally send a tug down the line along its filaments and actually influence particles back here, right now, or even particles in the past. So the gravity we feel pulling us down to Earth could, in part, actually be the pull of our own future. It's a wild thought.
All right, and if you thought that was a stretch, this is where the theory really takes a swan dive into the deep end. Because if all matter, all these filaments, are connected across time, what does that imply for something like life, or even consciousness?
Okay, brace yourself for this one. The theory suggests that we aren't separate individuals at all. Not really. Instead, all living things are physically connected through our filaments, making us all just tiny parts of one single, enormous, four-dimensional superorganism. I love this analogy. It's like we're all just fingers on a giant hand, but we can't see the arm that connects us all. So that feeling you have of being you, a separate person, it might just be an illusion, a trick of our limited three-dimensional view. So what does that do to the idea of free will? I mean, think about it. If this model is true, then our choices, our intentions, the things we think are coming from us, they might not be. They could just be coordinated signals, like little ripples moving through this massive time-spanning network, almost like muscles contracting in a body so huge we can't even begin to comprehend it. So after all that, what are we supposed to do with this idea? Is it right? Is it wrong? That might be the wrong question to ask. I think this whole framework is less about being a final answer and more about being a totally new lens to look through. The person who came up with this also gets pretty philosophical about it. They ask, can we even really say anything meaningful about a reality we can never, ever directly experience, like a fourth dimension? It kind of makes you stop and think, doesn't it? Are our scientific theories actually showing us what reality is, or are they just showing us how our own minds work? And maybe that's the real takeaway here. Whether the universe is actually made of filaments or not, maybe that's not the point. The true power of an idea this wild isn't about being proven right. It's about shaking up our assumptions, forcing us to look at old problems in a completely new way. It's about making us ask questions we didn't even know existed. So, what do you think? Is the goal to find the right map, or just to explore the territory?